overview and introduction. So what is OpenDaylight? So, forgive me if you kind of understand this or have been involved and know this, but the OpenDaylight project started, as an idea somewhere around last January of last year. And the idea was, a bunch of people had come together and realized they had the same idea, which was there's really not a whole lot of value in this sort of controller itself. And there were a lot of different splinter controller projects going on, and people sort of said, what's the value in reinventing the wheel every time when what we're really doing is reinventing infrastructure that should just be there? And the analogy that a lot of people arrived at was, it's like an operating system. It's like Linux, right? And so why should we keep building a new operating system every time? What we should be doing is innovating around that. And so we came together and formed the organization around that principle. And the idea was to then build, a collaborative open source, a truly community-based open source effort where we could do this. And, we've achieved that as of last week. Yay. And there are other functions and features now that I think you'll find that people are building on this infrastructure. So a lot of the NFV concepts, some overlay concepts, different plugins to different devices and architectures underneath. And so things are going as planned, and I hope things continue. So the project scope, so I want to tell you a little bit about the organization and how it operates, right? The organization itself, if you don't have the stick that's going around, raise your hand or ask somebody in your row to pass it around. There's a couple people came in. So the projects, sort of the project life cycle, there's a whole procedure and process that goes on in the organization for how to propose a project, have it accepted, and have it worked on. In fact, we're going to go through some of those in a bit. But the organization itself is constructed so that there's basically two halves of the organization. There's a board of directors and a TSC, although there's also a marketing organization as well. But the TSC, the Technical Steering Committee, which has representatives from all of the platinum members and then some silver members and some gold members, basically oversee the technical aspects of the projects. And so they determine, if projects meet the criteria to be accepted, to be worked on, and so on. And they also potentially do, disputes, kind of mitigation and stuff like that. And so once those projects are chosen and are underway, there's sufficient committers and so on, and coders for the project, the TSC grants the project status to continue. And so the TSC itself is actually chartered and limited to basically the areas that are described up here, right? So we're not going to be writing, car controller software or something. I mean, we're limited to, these areas, basically networking, anything you would think of in this sort of SDN NFV space, and the things that are necessary around those things to make those work. So obviously we have the OpenDaylight controller, and that was the first and main project that's underway. And then there's software for forwarding elements. So things like OVS, for example, are things that we work on or interact with other organizations. For example, OVS is a good example. OpenFlow is another example. And southbound plugins to enable a controller to speak to different network element types using different protocols. So things like netconf, OVS-DB, PCE, for example, things like that. And then network services that are built around the controller and then communicate to the controller through northbound plugins and interfaces, such as JSON and so on. And that's kind of where I mentioned the kind of very interesting innovations that I think are going to happen around the controller are going to come. Oh, and I forgot, plugins for intercontroller communication, although I don't think that's been really worked on yet. So who is in OpenDaylight? There's a lot of sponsors at varying levels in the organization. So the colors aren't seeming to render correctly here, but I've got platinum, gold, and silver. So platinum members, and by the way, all of this information is on OpenDaylight.org. If you go and look, and there's a governance tab, and you can find all of the governance and policies that I'm talking about. You can find all that online. And so we have platinum members. Each platinum member has a seat on the TSC, as well as on the board of directors in the organization. And gold members and silver members then have varying levels of seat assignments based on that level of sponsorship. And level of sponsorship is amount of money, basically, that you pay each year to sponsor, as well as the number of full-time engineering equivalent resources that you will commit to the project each year. So what are the project goals? And this can evolve over time, but these are the initial goals. To create robust and extensible open source code for SDN, basically, and to allow a community to develop that code. There are other organizations that have worked on things in this space and in other ways that are not, I wouldn't call them true open source organizations, and that's partially why this organization was founded under the Linux Foundation, because that, to us, is a key, very important sort of aspect of this project. We want it to be community driven so that it's widely adopted. And what that means is that anybody in this room can contribute code, just like with Linux, right? Anybody can add stuff to the kernel if they want, obviously through code review and acceptance, but it's not, sort of a political process that's required to get code committed or whatnot. I mean, it's a meritocracy, and so if your code sucks, it won't get in, but if it's good, then hey, that's okay. And that philosophy pervades the work that we're doing now, and hopefully will continue. Yeah, I think I mentioned that. So ODP, OpenDaylight project, is the first release of ODP is hydrogen. So you've probably heard about that over the last couple hours, or read about that. So hydrogen was the first release of basically the bootstrap projects, and varying versions of those are included in various builds, various packaging options of the controller. And so obviously, again, I mentioned we have the base controller, but then we have 5 other bootstrap projects, which are also very interesting in their own right. And then you also heard about some people talking earlier during the keynotes of some of the members have already taken this base code and built a controller or an application infrastructure around this for a commercial offering. And we hope that's going to continue. There are other incubation projects that are underway. So I mentioned there's a project life cycle, and projects are in different states. And again, this is on the wiki. You can go look this up. Projects are in a different state. In fact, there's many more states than these two. And so under incubation projects, we have things that are things that excuse me, weren't considered critical to the initial release of the controller. Not that they're not important, but we wanted to try to focus resources and development in those first 6 areas. that doesn't mean that work hasn't been underway in these last areas at the bottom. In fact, Yang tools, for example, and OVSDB are also, critical parts of the current version of the controller, as you'll find. Madhu is going to talk about OVS in a bit, and OVSDB for controlling that is a pretty interesting thing. Yang tools, you're missing the MD Sal session, which is next door, but Jan would be talking about how the Yang tools are used to actually generate and hopefully continue to generate a significant portion of the code. And it's a model-based architecture. And so these are the tools that are used to take your Yang file and generate code, basically. And I'll talk about a little example of that in a second. And then there's some other examples of other projects which are in various states and conditions. And so any of these projects, all of you in the room can actually contribute to. And I encourage you to look at them. Oh, and I have a thing too about the different editions I mentioned. So there's the base edition, virtualization edition, which has like multi-tenancy and some of the other functions, and then the service provider, and then Extra. I think Extra has some of the things that aren't included in the others. But all that info is on the wiki again, so all the details of that, and then you can pull each version of those and take a look at them for yourself. So as developers, this is the first place I'd recommend you go. Go to the wiki. Go to the wiki right now. Pull up the page. It's got all the info I'm going to talk about today. It was basically the script for this presentation and some of the other sessions. And so basically, this is a notepad, if you will, of where all the developers have put, sort of tips and techniques for how to actually work on this thing. There's also examples, coding examples, and things like that on here as well. So take a look at that. In fact, I think the browser comes up in the VM here as the default, one of the tabs. So a little bit about the architecture. So you'll see this picture on the wiki, but it's not necessarily explained in a heck of a lot of detail. And feel free to ask about any of these components either now or during the other sessions, because it may not be obvious kind of why they're in the position that they are in this framework or architecture, why they're not in other places, and what exactly do they do. But basically, if you look at the architecture for OpenDaylight, it's divided up into basically three strata. There's a sort of northbound / applications. We have the kind of middle infrastructure, which has certain functions. In fact, the SAL, the service abstraction layer, MD Sal, exists in here and generates a lot of these functions, or how the different functions interact. And infrastructure services. And then we have southbound plugins, so things like OVSDB, netconf, et cetera. The controller itself is built as a modern application architecture. So it's, for example, has RESTful APIs that can be used to control it. So there's a JSON interface, which if you open the VM again, you'll see we have a tab open for how to communicate with the controller through the REST API. And then the middle functions, are critical sort of infrastructure things, such as the topology manager, for example, the host tracker, the switch manager, statistics manager. So these are critical functions that other either applications built on top of this or other services inside of the controller will want to interact with. Think of them as sort of internal services of the operating system. And then, of course, southbound plugins interact in sort of in a kind of a cross-connection manner, the way I like to look at it. they're cross-connected with different northbound interfaces and services. So let's talk a little bit about the network lifecycle and how this works today. So how would I build an application now to interact with an application? Then again, is something that interacts with the controller. In fact, it could be inside of that middle layer, but doesn't have to be. It could be above. And how does that interact with, say, some network elements at the bottom? So, like in the VM that we gave you, the network at the bottom is a emulated network built through Mininet of NetFlow enabled switches. And so, how do you get your application to either talk to other applications or directly to the network elements? For example, to trigger a ping between two switches. And so let's imagine, we want to, feature change happens in the network element that's modeled, and we have API changes that are needed to reveal those changes. So the way that you would do that in the controller today is you would actually have to manually go in and modify the element as well as the northbound API as well as maybe the GUI to reveal that. So let's say I added a new statistic, interface bytes out or something, and I want to reveal that on the GUI for this. So you would have to actually go through and change all of these things, and also potentially change applications that consumed either the previous version of that or didn't even know about this. And that's kind of how you used to do application development. So how is this changed today? So this changed today using the MDSAL, the model-driven architecture, which so this is kind of like what's going on next door in 2 slides. So what you would do today is if you had a feature change, you would actually, first of all, you would model this and effectively generate the code with the Yang tools. And so what that auto generation would do is actually automatically generate, basically it's an RPC model. So it would generate the client and the server end stub functions that you would then have to go fill a little code in to actually make the action do the right thing. But the API is automatically generated, so the JSON interface is automatically generated for this. And you can also automatically generate potentially auto-generate the GUI, and also auto-generate components that are in the application above that. And so this is actually an evolution that happens sort of halfway through the first release. And this was a very cool and useful change. And I think Madhu's going to show some of that stuff later as well in his demo. So a little bit more about MDSAL. So I'll kind of go through a little bit in detail here. So the way that things look internally, I've kind of exploded the abstraction layer now in the middle. And so if you go through the source code of the controller, you'll find there's a directory that has all these Yang models in it. And the Yang models depict basically things like topology and things that are in the topology, network elements, flows, system attributes, various configuration options. And pretty much everything in the controller eventually will be modeled like this. And then the code will be generated for the southbound APIs as well as the northbound APIs. So most of the code in the controller is actually auto-generated. This was like the joke that we were whispering about this morning when somebody said, yay, we've checked in 1 million lines of code. And we said, well, 800,000 of those lines are auto-generated. But that's actually a very good thing because there's very little that you actually have to change If the model is right, the code gets generated and you modify very little of the code, and bug fixes happen in there. Or if you discover that there's a larger problem that happens to be in the auto-generated code, what do? You just regenerate the code, right? In fact, the architecture allows you to reload that code at runtime. So you don't have to reboot the controller or anything, generally speaking. In fact, applications that are built like this too can dynamically regenerate themselves or portions of themselves, which is cool as well. So from your perspective, what's going on in here? And I think I've kind of covered this a little bit, but, oops, sorry. What's going on? So it's basically, again, it's an RPC model. It's a producer-consumer model. So you have a client and a server. So you can imagine, an example of an application having to talk, an application as a consumer wanting to talk to a producer of statistics, right? For example, like interface counters. And so, you have a southbound protocol or a southbound plugin that talks through a southbound protocol to effectively generate data. Data comes into the controller and then gets fed up to the other end of the RPC that is registered for that type of information. So this was an example of how to add clustering, which actually may not be so interesting at this point. But basically, has this been added yet, Madhu? The message bus piece at the bottom?
So the clustering is working today on the AD-cell approach, but the MD-cell is not, it's not operational yet.
Yeah, okay. That's what I thought. I'll just skip that. So this is an example of the RPC mechanism that I was talking about. So, excuse me. You can see in the example, where's my pointer? Here it is. So we have the model basically here that defines a node flow and a couple of other attributes. And so what we do is we take this Yang file, we run it through the Yang tools, and then we'll generate this API, which generates this function, or these three functions, actually more than that, but and effectively you get you get both sides of the RPC function generated, and so you have to fill those in. And then those functions are reloaded into the controller, and voila. So this actually shows kind of more pictorially what's going on. So imagine the code was generated and is reloaded. And so now what happens? So when the test flow function is called, the sal flow service API gets invoked. Where are we going here? Oh, there we go. So, yeah, sorry, it's not drawing the way that I expected to. So the test flow service, for example, when you invoke this command, corresponds to an element in the topology. So you give it a target that you want to basically let's ping. And so that information is associated and sent to the function. Whoop. Here we go. So we're going to ping from this guy to this guy. And so there we go. apologize. These aren't rendering right. I don't know why. They looked okay yesterday. I don't know. What happened, Madhu? There we go. So you go and you would invoke the command. You would go through, find your route, send your ping out, and collect the response, and then return that back as the result of the function call. Here we go. There we go. And I think in this example, yeah, so this is more of showing the RPC client and service. How the messaging comes around internally. And so this is actually an example of how like routing requests would happen from an application to a network element. So an application, again, being built on top of the controller. So you would make requests through the RESTconf interface. So we'll show that here once we draw the, or netconf. Here we go. So again, we have the topology model here. So I've picked network element 1 out of the topology, which again is available through the northbound API. So then the application would decide, I'm going to send a message from, I want to ping from network element 1 to network element 2. So rather than going through the internal interface, I'm going to, again, use the netconf interface. And it's basically the same paradigm that we had before. Go walk through this. So here's your RESTconf call for that same command. So you can use various interfaces to do this as well, which is also part of the example. And then the response comes back, again, through the netconf interface. So this is multiple destinations, so multiple multiple pings. So, yep. I mean, it's basically the same model. Just kind of walking through the different iterations. So does that all make sense? No? No? It'll make more sense, I think, when we go through some of the examples. But sorry, go ahead. Yeah.
I have a question on the southbound APIs.
Sure.
What is the minimum requirements for the southbound APIs? How many APIs or plugins do you require for the OpenDaylight web?
So he's asking how many southbound plugins do you need for the controller to be functional? Just one. Any of them. I mean, you have to talk to network elements somehow. So in the example that we give out, the OpenFlow plugin is there, but that's only an example. That's not mandatory. So you just need to be able to talk to something. In fact, I mean, I think you can theoretically run the controller without any southbound interfaces. It just won't do anything. Right? I mean, you need at least one. And the requirement is it's got to talk to something.
So let me be more specific. How do you negotiate, for example, I don't want to use OVSDB. So how do you negotiate that?
No, thanks.
How would you negotiate that the plugin is, OVSDB plugin is not there, but there is some other plugin available which will provide the same service as OVSDB?
So, go ahead.
So the service abstraction layer is, I'll go over the details on the bundles and how OSGI works, so on and so forth. The OSGI provides a service registry concept where multiple providers can come and register themselves when they come up. So OSDB is one plugin will come and say, you know what, I support configuration servers and certain services. OpenFlow, on the other hand, will never say I support configuration service because OpenFlow is a data path protocol. So it will say, mostly it will say data path services and flow programmer service. So when the plugins come up, when they register themselves to the SAL, they express what they are capable of. And hence, SAL knows which plugin is capable of what and expresses the same thing to the up north to the service functions.
Can there be two plugins which provide you the same service?
It can.
Yeah.
It can. The way we differentiate is when the plugin comes up, they will express themselves what kind of node they support. So in this case of OBS DB, they will say, you know what, I am the guy who's going to help you with the OBS nodes.
So how do you identify the OBS?
Again, that's a plugin one. The plugin will, when the plugin comes up, it's a responsibility to connect to the OBS boxes, right? Because it's simple. Southbound plugins talk one language, typically, right? OBS DB talks Open vSwitch DB protocol. OpenFlow talks OpenFlow protocol. NetConf talks NetConf protocol. So that's the only, the plugin understands only that language, right? So
I want to do some operation on some remote node, and it does not talk OBS DB, but it talks some other, and I have a plugin. How would when the application issues a command, how does it goes down into your framework and figures out that I need to use this XYZ protocol, not OBS DB, to actually do some configuration on the remote node?
So that's identified in the topology, for example. So when you explore the topology, you can identify what the capabilities are of those nodes.
So the node.
It's sort of like, just like with an EMS or an NMS today, where you go and explore the device using NetConf and you say, hey, let me hear, what's your model? Give me your model, right? It's a similar concept. The topology will note capabilities of the nodes.
right. So a node has two types. One is the node type and node identifier.
Yeah.
So node identifier is just a unique identifier, a unique identifier for a given node. The node type is the mux and demux. The node type suggests what kind of node it is. And that's how the SAL knows, okay, that this node supports NetConf or OSDB. And based on the node type, the appropriate plugin will be loaded and then routed towards that.
If I issue an operation which is not supported by NetConf, but is supported by OBS DB,
That means you need to have the OSDB plugin.
so
And
how would OpenDaylight deal with that situation?
Well, it would fail if it didn't.
I'm saying if I want to, the application, application is a single application and there are heterogeneous nodes.
Right.
An application issues a operation which requires something which can be done by OBS DB but cannot be done by NetConf. What will happen?
right, so if you look at the
So
way,
I'm sorry, so you're saying if you issue a command to,
The application would require something, for example, routing or say, let's say,
Yep.
security grouping, for example. Security grouping can be done with OBS DB but cannot be done by NetConf. How would that happen? How would
okay.
OpenDaylight deal with that?
Our driver is not that under something can operate one of us various command. So it's any new service that you are bringing up, you need to have a plugin.
No, but what I'm saying is, how does, yes, I agree with you, it's not going to happen, but how does OpenDaylight deal with it? Because I have a heterogeneous environment and I'm issuing an operation which will happen on n nodes, but will not happen on n minus x nodes.
so if you can hold this thought for my session, because in my session, we're going to see a hands-on lab on OBS, essentially. You're going to see how the same OBS instance is going to talk both OpenFlow and OBS DB, right? And you will know that SAL will take care of programming the channels via OpenFlow while configure using OBS DB.
No, I
And
understand that,
now-
but what I was saying was the configuration part where you have two different configuration protocols. How would you?
Yeah, because the configuration, the way the configuration comes up, the capabilities exchange. And if you look at the MDSAL approach, you saw that the tree is found based on the capabilities itself, right? So based on the node position that you are in, and based on the capabilities being exchanged, the SAL will know exactly which plugin is the right plugin to choose for a given operation.
I think he's also asking if there's two that you can use. How do you choose? The application can choose.
Yeah.
In OpenStack,
Yeah.
you have made two plugins,
Right.
Where you can have multiple plugins on
Yeah.
heterogeneous network. So how does in OpenStack ML2, you basically say for this subnet use this plugin, for this subnet use this plugin.
Correct.
We have something like demarcation here where you divide the network into two things and then hand it off to each plugin.
Well, today the way it is done is application can express what node type you want to address this one, the operation on. You can express that.
Application has no knowledge of the node because you want to run
Right.
a modified application, it wants to issue an operation, you convert it into some routing.
Right.
And the routing protocols used by different nodes is different, so how do you actually go about and do that?
Right. Okay. So there are a couple of answers for that. So this is a service called Node Mapper. Node Mapper is something running in MD cell. It's not in AD cell yet, right? What Node Mapper does is it tries to organize the different nodes into various categories, right? And based on the categories a node belongs to, different sub plugin it has, it automatically figures out which plugin to take, right?
So when the node comes up, does it advertise itself what its capability?
Right.
Yes.
Right. That's exactly where SAL registration happens that way.
So that's what I mean by the advertising model. It's just like an EMS works today. I mean, it has to discover the nodes, but,
I
oh,
understand now, okay.
yeah.
So I get it.
And that's nice because you can discover the capabilities as you go.
Okay.
Cool. Let's see. How much time do we have left? Is it 15 minutes? We over at 2:30?
There's a clock there.
At 15 minutes, okay.
I think we break at 2:20 or something, and then you have a 10 minutes break, I think, right?
Oh, it's at 2:20. All right.
I had to check, yeah.
We'll wrap it up quick, 5 minutes. All right, so plug-in build process. Yeah. So how do you build a southbound plug-in? Like, and I'm going to go through the OpenFlow plug-in example real quick. So you'll actually see this with the VM that you have, and I think Madhu will do a build example as part of that. I don't know, are you going to build a controller? I think you left. I'll show you how to build a controller in my section anyway. So you'll see this actually happen. So you take the Yang model, you plug that into the Yang tools, and you generate the API for MD-SAL examples. Today, actually, there are non-MD-SAL things that are still part of the controller. So you may not use those, auto-generated tools as well. Basically take that, use the Maven build tools. Those generate code. Then those are loaded in. The API gets loaded into the OSGI bundle. So the controller as you'll see, is an OSGI container with a variety of bundles that are loaded into it. And those bundles get loaded, both the plugin and the API both get loaded into the bundle and deployed into the controller. So again, it's a fairly automated process. OpenFlow plugin architecture. So to take a real example that's working that you'll see. So here are the various components that are inside of the OpenFlow plugin. And as you can see, the OpenFlow plugin actually interacts with other sort of parts of the sort of controller guts, as I call them. So you can see it interacts with the topology service. So like in the example we were just talking about with this gentleman here, the node has to identify itself and its capabilities. And so this is part of how it does that using this protocol. There's a flow service, a stats service, for example, for pulling stats out of the device, and packet handler. So when packets come from the device, for normal rule, for example, in OpenFlow, what do you do with that packet? So this is where that stuff gets handled, and where the code gets written to handle that. Yeah, I think that was all I was going to go through. So real quick, so how do you receive a flow delete message through the system? So going through, so a message comes into the controller, goes through the OpenFlow library and plugin, gets punted to the plugin. Whoops, sorry. We'll pass through the OpenFlow API, and then we'll go to the flow programming service, which is registered to receive those messages. Messages are handled, and a potential response may get sent back down through the system as well. Flow programming service may interact with other stuff inside of the controller to make a decision on how to send back that message. for example. You can also add a flow using the RESTconf netconf interface. We went through that a couple of slides ago. You can talk through that. That'll talk through the flow programming service, which will then issue a message down through the OpenFlow plugin as well that will go to the device. Real quick, again, key concepts to keep in mind through the sessions that are going to happen. Coding is mostly done in Java and Python, mostly Java. OSGI, again, is the kind of container HAISSU model for the controller. Bundles are loaded, reloaded, unloaded through the console or through the interface in OSGI. For developer tools, and I think most of these are loaded in the VM, IRC is the communication tool. So if you want to follow, even right now, there's probably some IRC chat going on. That's how all the developers interact, pretty much. That and Twitter randomly. Maven is the build manager. This is the build tool that's used to assemble the projects. Git is used as a code repository. So Git is where we store the code, how we manage the code versioning, and et cetera, as well as with Garrett, which is used for code review and diffs, changes, and so on. And there's, in fact, on the wiki, you'll see there's a best practices and kind of code conduct for how code is reviewed and checked in. Familiar yourself with that. So it's not as easy as just checking out some code and making a change and checking it back in. There's a review process that has to happen. Eclipse, the Eclipse IDE is optional. Obviously, if you want to use Emacs or VI or whatever to write your code and whatnot, that it still works that way. In fact, I just started using Eclipse myself on this project about 2 weeks ago. Until then, I was just using Emacs and sort of like that, and the CLI, and a lot of people still do that too. Let's see. Code is the coin of the realm here. So code, code, code. That's hopefully what we're trying to get you all to do. And that's how influence comes in this project. So if you want to, you want to influence the direction of a project, make changes, come and write the code and get it to work. And if it works and it works well, it's going to be pretty hard to not do that. Bring your ideas. Don't be embarrassed. Don't hold back. If you have cool ideas you want to do, bring it to the community and see. And I think this is my last one. So just some resources for you again. The wiki and all the stuff that I've talked about today is on OpenDaylight.org, including these slides that will be available on OpenDaylight.org. Our normal IRC channel is OpenDaylight, although there's one for each of the projects now as well. And it's, anybody can get on IRC free node. We have some mailing lists, which anybody can subscribe to. They're all open, including the TSC list. I think the board list is open too. Twitter and on Facebook. I think they're on Facebook as well. So, and that's it. So hopefully that was a decent introduction. So if you hang out in our next session, Madhu's going to do a very hands-on example, and after that I'll show you how to pull the code, build the code, and then Lewis is going to follow up with some testing. Cool, thank you. Disputes, kind of mitigation and stuff like that. And so once those projects are chosen and are underway, there's sufficient committers and so on, and coders for the project, the TSC grants the project status to continue. And so the TSC itself is actually chartered and limited to basically the areas that are described up here, right? So we're not going to be writing, car controller software or something. I mean, we're limited to, these areas, basically networking, anything you would think of in this sort of SDN NFV space, and the things that are necessary around those things to make those work. So obviously we have the OpenDaylight controller, and that was the first and main project that's underway. And then there's software for forwarding elements. So things like OVS, for example, are things that we work on or interact with other row to pass it around. There's a couple people came in. So the projects, sort of the project life cycle, there's a whole procedure and process that goes on in the organization for how to propose a project, have it accepted, and have it worked on. In fact, we're going to go through some of those in a bit. But the organization itself is constructed so that there's basically two halves of the organization. There's a board of directors and a TSC, although there's also a marketing organization as well. But the TSC, the Technical Steering Committee, which has representatives from all of the platinum members and then some silver members and some gold members, basically oversee the technical aspects of the projects. And so they determine, if projects meet the criteria to be accepted, to be worked on, and so on. And they also potentially do organizations. For example, OVS is a good example. OpenFlow is another example. And southbound plugins to enable a controller to speak to different network element types using different protocols. So things like netconf, OVSDB, PCE, for example, things like that. And then network services that are built around the controller and then communicate to the controller through northbound plugins and interfaces, such as JSON and so on. And that's kind of where I mentioned the kind of very interesting innovations that I think are going to happen around the controller are going to come. And I forgot, plugins for intercontroller communication, although I don't think that's been really worked on yet. So who is in OpenDaylight? There's a lot of sponsors at different varying levels in the organization. Overview and introduction. So what is OpenDaylight? So, forgive me if you kind of understand this or have been involved and know this, but the OpenDaylight project started, as an idea somewhere around last January of last year. And the idea was, a bunch of people had come together and realized they had the same idea, which was there's really not a whole lot of value in this sort of controller itself. And there were a lot of different splinter controller projects going on, and people sort of said, what's the value in reinventing the wheel every time when what we're really doing is reinventing infrastructure that should just be there? And the analogy that a lot of people arrived at was, it's like an operating system. It's like Linux, right? And so why should we keep building a new operating system every time? What we should be doing is innovating around that. And so we came together and formed the organization around that principle. And the idea was to then build, a collaborative open source, a truly community-based open source effort where we could do this. And, we've achieved that as of last week. Yay. So and there are other functions and features now that I think you'll find that people are building on this infrastructure. So a lot of the NFV concepts, some overlay concepts, different plugins to different devices and architectures underneath. And so things are going as planned, and I hope things continue. So the project scope, so I want to tell you a little bit about the organization and how it operates, right? The organization itself, if you don't have the stick that's going around, raise your hand or ask somebody in your